Stanford University.
Welcome to the seminar on People, Computers, and Design. I'm Terry Winograd, and we're into our second week now of the winter quarter series. So since it's still early, let me just repeat the logistics quickly. If you're taking the course for credit, you need to watch all 10 talks, but up to 2 of those can be done remotely if you miss class. 8 of them have to be in person. There's a sign-up sheet that'll go around. Leslie over there has it, so if you don't get it during the course, grab her at the end, and she can take care of it. That's to get credit. You need to do that. If you're not interested in getting 1 unit credit for this, just come and enjoy. No requirements. Also, there is a mailing list that can send out the weekly notices. That's all on the webpage, hci.stanford.edu/seminar. So you can find out and see who the speakers are, what's coming up. Next week, we have Meredith Ringel Morris, who is one of our illustrious graduates. She was part of this group and has been working for several years at Microsoft Research, where she's been doing research on, let me say roughly, social search. So it's the intersection between how people search and how they interact with their social network of people online, and how those can play a role in each other. So that will be our speaker for next week. This week we have Dan Russell, who, and I always say this, we've had him here many times, he was the initiator of this series. Our first talk back in 1990. Some of you weren't even born then, right? In those years, he has been an important person in research in a number of really interesting and important places. So I first knew him at Xerox PARC, which is sort of the founding legend of our online world, or our computer world. He was at Apple during some of the very productive years there. He was then at IBM Research Center here in Almadane. And he has now for several years been at Google. So he knows where all the good places are, and has been able to sort of put a stamp on what goes on in each of those. And in particular, his general interest, which he has then pursued in all of these contexts, is how do people make sense of the world around them. And in particular, the information world, since that's the business we're in. So the topic of sense-making, I don't know if that was the title of your original talk years ago, but it could have been one of the titles from very early on, because that's been a continuing thing. And the fascinating thing is, of course, that as new technologies come and as people change the ways they interact with them, new things happen. We don't make sense of the world the same way we did 20 years ago. So very glad to have Dan Russell on Sensemaking.
Great, thank you. So as Terry pointed out, this really is Sensemaking 3, the third time I've talked about this particular topic. And it's one of these topics that was actually one of the motivating forces of my career. I've always been interested in how people collect information and what the heck they do with it. I was interested in that back in about 1990, actually. So the first talk was actually not on sensemaking, it's on something else. But I got very interested when I was at PARC, working for Stu Card, and we got a dialogue account. Many of you have no idea what this is. It was like pre-Google. You could do free text search over the newspaper space. So like Google News. Like that. Fantastic resource. Changed my life when I was going to give a presentation in Washington, D.C. I did a quick dialogue search for this person I was giving the presentation to. I was going to give a talk on why we need to do X. I had discovered that the previous month, this general had given a talk saying why we should not do X. That was an important thing to know. And ever since, I've been really interested in how people manage to find, organize, and use information, because at that time, it was very clear where the memory curves were going to go. They were going to go up and to the right. It was clear where the cost curves were going to go, down and to the right. And that meant that everybody was going to have something like dialogue. We'd be able to do these very large, very broad scale searches. I didn't know that Google was in the future, but everything was pointing in that direction. So I wanted to sort of start to understand that. And that's how I got here. So we'll flash forward through a few years of this in between. Let me start by giving you a quick definition of what I mean by sense making. It's really this whole sort of process of coming to understand a large or complex set of information that you gather and try to organize in order to get something done. Okay? What I'm especially interested in is what do we do to sort of distribute that out into the world? How do we externalize it in order to be able to use the sort of cognitively wonderful properties of external memory in distributed representations? So in particular, I'm going to frame sense making as collecting, searching for, collecting information, organizing that information, searching for that organization, because I bet you don't get it right the first time, and then interpreting it and using it to get some task done. Okay? So I'll give you a little bit of background here, and then we'll go into some examples of that. First thing I want you to realize is the world is really different now. How many of you have used one of these, Guide to the Periodical Index, the Guide to Periodical Literature? Okay, let's say 10% of you. That's roughly 35 and up group. Okay, I know who you are. Now the thing is that this was like this is a manual version of Google Index, in essence, and it was accumulated by a company, and they would publish updates and so this is manual index updating, right? And it's one-way links. So you would do is you search, say, for example, for high technology industries. You would go to this appropriate thing, and now, because it was by time, you had to go back and search all the previous emitted versions of this. So it's kind of a hassle. And there were one-way links. They went out into the literature. There was no way to come back, really. So the world is fundamentally different because now this is all computable, and we have fantastic search engines that allow you to manipulate that. And that's what I want to talk about. How do we manipulate our tools to get the data to do interesting things? Let me give you 3 categories of examples to start. Let's start first with scientific, and I'll talk a little bit about how people in the intelligence world organize themselves, and talk a little bit about collective sense making. So let's step back. You remember the scientific method. You probably all studied this in grade school. We all engage in it sort of day to day here. You do experiments, you write papers, you distribute, and the classic cycle time for this has been relatively slow. And one of the interesting things that's going on now is how that cycle time is speeding up with web-based distribution, publication, data sets being put out onto the web, people being able to analyze them, and so on. Now, one of the classic cases here is, of course, Newton's publication in 1687 of Principia Mathematica, where he formulated laws of motion, all kinds of great work. Right? The interesting thing about this, when you start looking at it historically, is he created a set of representations to do particular kinds of tasks. He looked at data, he had his theoretical models, and emitted, this paper, this book, basically, which said, here's the set of representations I find useful for describing motion in this way. Excellent. Problem. Fast forward now a little bit. We get into Einsteinian time. The big issue with Newtonian mechanics is it doesn't work well at the margin, at very high velocities, very long distances. And so you have Einstein in 1916 publishing his paper about relativistic effects. And what he discovered, what Einstein was doing, was discovering the residue in the Newtonian model. That residue, he said, well, gee, I can explain what's going on when you get close to the speed of light. And so he was re-sense making those models of motion in order to account for effects that Newton didn't understand, couldn't measure, had no idea about. So in some sense, this is a classical Kuhnian revolution. Take one model and supplant it with a new one that accounts for the data more accurately, more completely. So you think of scientific progress as sense-making of a kind where it lasts over generations. Well, we all know what happened with the weapons of mass destruction analysis. Right? It didn't work out so well. There's a bunch of data collected, a bunch of analysis done, and then the commission to report on the failure of sense-making for weapons of mass destruction analysis said they have to explain what they don't know. In that very Rumsfeldian phrase, you have to explain, that you don't know what you don't know what you don't know, right? And so this is an interesting failure of sense-making for many reasons. You can go into and read the report. There are political reasons and data collection reasons. There was also big time pressure. reason. Keep that in mind, because that's going to characterize sense-making basically in our lifetime. Massive quantities, little time. How did they deal with it? In this case, they didn't deal very well with it. How can we make our work with those constraints better? Now, I have to give you a little example of sort of collective sense-making. And how many of you know about the heavy metal umlaut Wikipedia page? Okay, a couple of you. If you haven't read it, open up a browser and go check it out. Or more importantly, watch for a second, because this article in Wikipedia was started in 2003. Go check the history. That was the first entry. A heavy metal umlaut is that diaeresis, like an Uber, or the double diaeresis over the O in blue oyster cult, that kind of stuff. It's sort of artificial. But what happened is that people started, in the Wikipedia style, editing, reversioning, and having this discussion. And you know what it's like. Let me ask you, maybe, how many of you have edited Wikipedia articles? Yes? Okay, say a third. That's pretty good. That's pretty good. Thank you. Well, what's interesting about this is how the discussion went on and on. People would say, here's a phenomena I want to account for. Here's another one that doesn't matter. So you're having essentially a scientific / humanitarian / cultural argument in this space. Is this an important phenomena? Doesn't matter. What you're seeing is people trying to take all the observable behavior about heavy metal death thrash bands and their naming properties and convert it into a learned article. That's really what's happening. Okay. Anyway, if you have a few moments, I highly recommend going and checking out John Udell's summary of this process. That is a marvelous screencast where he reviews the entire history. Now, Jeff here worked with Fernando Villegas and Martin Wattenberg a few years ago to build a kind of visualization system that people could then comment on. This is another kind of beautiful collective action towards understanding the data here. So you could have these, for example, these annotations, and you could have this sort of threaded conversation-like thing on the right-hand side where people say, you know, that fall was not due to this economic reason, it was due to this political reason, or whatever. So you had this fascinating discussion as people would try to present data and say, oh, no. These jumps have to do with the economy at large, and they went back and forth, back and forth. So I'm not claiming this is the same as Einsteinian revolution, but you see a similar kind of scientific sense-making going on as people present data, argue about interpretation, and re-represent that. That is, in this case, they're layering new interpretations physically on top of the graphs and on top of the data. So a couple of years ago, I did a study with Lily Irani and Robin Jeffries and a few folks, and we studied how people were using Google spreadsheets. And we were overtly looking for evidence that they were using them to do sense-making. That is, that they were actually taking them, modifying a representation, and seeing whether or not it actually happened. So we did this, and we discovered some really interesting things here. First off, most Google spreadsheets are not used for spreadsheet purposes. Or rather, something like 50% of them have no arithmetic functions in them whatsoever. 0. Okay? That was an interesting finding, which meant what? That they were using spreadsheets for something other. They were using them as a rectangular grid of easily manipulable elements that you could dump stuff into and fool around with. So we discovered that of the spreadsheets we investigated, we looked at in detail and did a bunch of interviews with the people, the owners of them. We discovered that they make these significant changes over time in collaboration with their partners. None of them were single person working alone. It was fascinating to see that they would do things like adding new data columns, they'd refactor the rows and add new dimensions, they'd add new representational mechanisms and so on. So here's one example. It's slightly anonymized. It's a bunch of people trying to schedule a vacation together. So they start with this representation, and then, whoop, we're going to transpose that guy because it doesn't work well vertically. We're going to do it horizontally. That's a big representation change. Then they start doing blocks, they start adding names, they start adding colors as representational mechanism. They're denoting acceptable and non-acceptable dates. You get to see this very fascinating change over time, where a group of people having a single spreadsheet argue about whether or not a particular kind of dimension should be in there or not. And so this was a typical graph. You see, this is over a course of a month, You see people making substantial changes basically every couple of days when they're actively using this, searching for a representation that works for them, that works to solve their problem. So this is all in effort to try to do sense-making the way I've been characterizing it. So for them, the key features were that they were shared documents. They didn't have to mail Excel spreadsheets back and forth to each other. They could do nice, easy operations like sort or change the view or go back and review the history of edits. They could add new dimensions. There were lots of representational change characteristics that helped them out. So that was a big win for us. Now, let me give you another example, my last example, which is very different than the other kinds of sense-making. We talked a little bit about mathematical models, models of physics, models of motion, how people use spreadsheets to represent data, and so on. Here's a different representation that will probably appeal to the designers in the audience. Here, the goal is to understand necessary conditions for building a new kind of laptop, and this is when I was at Apple in '94. We wanted to build a new portable, and so this is what we did. We made a cartoon, right? This is design by imagination. And so we told this story, in this case, of the product that we were working, the research project was called Vademecum, the thing you carry with you in Latin. And we had a kid from RISD tell this story about a bunch of underwater archaeologists using these devices and what it would be like. This is a real envisionment exercise. If you've got a laptop underwater, what do you need? How can you get the prerequisites for that device by imagining this in situ? And so we worked this whole fantastic story. And there's Jennifer, the diver, jumping into the water with the Vademecum. Here's Jacques, the master diver, saying where to go. We told the whole story. It's a great thing. And we imagined things like, this is '94, remember. This is in the dark ages. We imagined wireless communication. We had embedded cameras, blah, 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 all this stuff, right? We imagined stitching from the video frames as you swept by, which is now in my phone, which is, marvelous thing. We had a whole cast of personas and characters, including Ben, the ex-expert diver with a crippled left leg, due to the bends, and Black Evil Death, all important characters. But we told this story, and in telling the story, we imagined what it would really be like to use this. And this was an important frame out of that animation, out of that cartoon, where Jennifer dives in the water, and I talked to Carl and said, anybody who jumps into the water with that is going to get ripped out of their hands. So he fixed it. He added the handle. Okay? So this is exactly what one of the great things about visual design and telling stories and all that. We realized that people like kids, people like scuba divers, they need a handle. So we built a prototype, '94. I still have this. It's in my office at work. So this is a Duo. Remember Duos? Anybody remember Duo? No, it's okay. It's an early Apple laptop. Okay. Early Apple laptop, we put a touchscreen on top of it, a Metro Ricochet Network wireless card in it. We had an embedded camera. We had a handle. In this case, cards out of a 2x4. Okay. A couple years later, the eMate, based on Newton OS 2, shipped. The salient feature there was it had a handle. Okay? It's modest technology transfer. Right? But in telling that story, you're trying to sell this to a bunch of kids with greasy fingers from chicken nuggets at lunchtime. This is exactly what they need. So then a couple years later, out comes the iBook. And if you probably remember, there's Steve showing it actually has a handle embedded in it. He doesn't trust the handle, see, just in case. But you see this nice progression from the initial ideation through the prototype, through the eMate, through the iBook. It's a small thing, but it was an important thing because it helped us collectively see how this thing would work and how it might fail. So some of the lessons I derived from this sort of walk through sense-making history is we have a scientific approach where it often takes a lot of time, usually involves one person working alone, but then collectively we as a culture start to make sense out of all of those pieces and how they fit together, how the residue has to change and be identified and explained away. We talked about, how people working together can be subject to bias and confirmation effects, especially under pressure. When you do things like Wikipedia articles, or as you probably all do, using some kind of shared in the cloud documentation, what that sense-making process is like. We can then get this kind of collective imperative where we all want to contribute, and what we're trying to do is build technology to support that. So we don't step on each other's toes, and we can see the progression of work over time. That same thing is true for more structured representational mechanisms like spreadsheets. So Google Spreadsheets gives basically baby-level representational support, right? This is not first-order predicate calculus. That's okay, right? It allows you to do a lot of stuff very easily. And then, of course, there are alternative ways to understand how to make sense of something, and envisionment and by design is one of those mechanisms. Okay? Now, let me step back or over here to the side and tell you the rest of the story, right? I'm not the only sense maker in the planet. There's a whole industry of people out there doing this. Probably the best known are these three folks. Brenda Jervin started working on this from a sort of, what does it say there? A meta theory about communication research. And what she's interested in is understanding how do people get access to information. So it's very much a kind of library-centric focus. How do we give the right people the right information and make access available to everybody so they can make sense of their world? Right? She's been doing that at Ohio State for 30 years now. Carl Weick at the University of Michigan has a more sort of, you think of it as in a managerial context more. So he writes a lot of books from a business administration management perspective. How can teams make sense out of business situations and work together in order to make the work of the company or the unit more effective? Right? So he's got that thing. It's all about social cognition and how these groups work together in order to effect action. And the third sort of best known sense maker is Gary Klein, who works a lot with the Defense Department, advising teams how they can make sense of a complex situation under extreme time pressures. So he's worried about, an infantry unit going into battle and it's hell on earth out there. How do we get information in and coordinate our action together effectively? So think about that in the context. And then in 1993, Stu, Pete Paroli, myself, a couple other folks wrote this paper about the cost structure of sense making. And what this paper is about is really trying to say that sense making is this process I've been saying, and it's more than just looking stuff up. It's more than just making a graph. It's the whole behavioral aggregate of what people do. It's not just this any one tiny little piece. It's the whole melange of what people do in order to get to effective action by analyzing and creating representations. And so this was the diagram, the key diagram from that paper that we wrote, where we've got basically sense-making identified as sort of three major components. You search for a good representation. Right? In many cases, people already know the representation they want to use, and they just are filling it out. But at some point, you actually had to decide, I'm going to do a chronologically sorted list of events in my calendar, or whatever. So you have to do that. In complex tasks, like, say, the Newtonian task, that's a big deal. You're going around and constantly trying to find what a better representation would be. So we call that the generation loop. The second big thing here is instantiating that representation. So you build your model, you fill it in with stuff, and you try to build these, what we call encodons, punning on the term codon, where you get little pieces of data and cram it into your representation and see if it works. And when things don't work, you get this residue you have to explain. You have to go back and shift the representation. Say, like in the spreadsheets example, add a new dimension, transpose the matrix, right? All those kinds of shifts. And eventually you get down to a point where you've got enough data in your representation, you can actually do the work. So you can go do something, right? So the problem here is, how do we search for appropriate representations? How do we search for data? Notice the search word. How do we gather those documents, those pieces and fragments of knowledge, and organize them into a structure that we can actually use? And the point of the paper was that each of these steps, each of these modules, has a particular cost characteristic. Right? So this is Stu Card language, right? You have a cost function for each of these steps that you're trying to understand and minimize. Right? And so the normative model here is that you want to sort of minimize all these steps. The truth is people are not normative, they're just ordinary folks. They sort of satisfy their way through the universe. And that's kind of what's happening here. But remember this cost model, because we'll come back to it. Okay? One of the big things is, you know, you go off and you choose a representation, you find your data, you fill it in, you start doing the task, and it doesn't work. That's called refactoring, right? That's what we do in software engineering. The code's kind of a mess, it doesn't actually work, and I want to do this new task, I refactor it, right? So what that means is what we're really doing is in the face of bald reality and failure, we actually go back and perhaps change the representation. This is the sense-making loop, all this stuff right here. Okay. Now, I've come to think about sense-making as more than just spreadsheets and graphs on a dime. I think of it more as this sort of welter of knowledge, this sort of interlacing of both formal representations and informal awareness of the world. So John, my contractor, has a formal representation in blueprint space of what the remodel to my house should be. He's also got a pretty formal spreadsheet, which tells him what the expected costs will be, what change orders will be, and all that. But he's also got in his head this sort of mental model of what it means to make a house in Palo Alto and all the agonies associated with getting a plan through the planning department. So he's got a lot of internal knowledge which interacts with all this external stuff. And the line is not always real clear, but that's sort of the nature of distributed representations. So sense-making is really trying to understand, from my perspective, how do people do this? What do they do? And this is, like I said, what sort of motivated the last 20 years of my work. So do people, for example, put all their facts into a giant SQL database? Well, not me, right? Do they call up their friends? A lot. Do they use Google? Yeah, a lot. One of the things we don't know, though, is what the boundary conditions are. Right? When is it actually more effective for you to build a MySQL database and then issue select blah, 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 blah commands? So I'm interested in trying to understand this. And so one of the things I'm realizing, Jeff has a question. Sure.
Isn't there like a key implicit dimension here than which people? Because that part A there is used by tons of companies quite effectively.
Absolutely.
But it's a different scale and a different goal.
Yeah. That's a good catch. There's sense-making for the high-end technorati, like us, and the companies we represent. And there's sort of sense-making for the rest of the world, right? And so you're right, it's actually...
Even the technorati are a small proportion of the number of people involved in the sense-making loop that involves that, say, massive data warehouse.
Yeah. No, it's a good question, but I'm going to punt it for right now and come back to it because it's absolutely important and fascinating, but save it for the end, okay? Okay. So one big problem is the TLDR problem. Does anybody not know this meta idea, right? Too long, did not read. Okay? So interesting question. I know it's called a meme. What else is it called? I will leave that as a problem for you. Okay? But the TLDR problem is a massive problem, and it affects all of us now. It especially affects people doing intelligence analysis of things like WMD, because imagine you're an Intel analyst, and you're sitting in Fort Meade. Somebody gives you literally 10,000 cables and a stack of paper like this. And your report is due to the president by 5. It's 3. TLDR. Okay? They have to do something. They got to do something. So what do? So a couple of years ago, working with Malcolm Slaney, who's now at Yahoo, and Yan Shu, who's now at Maryland, we did a couple of experiments which were sort of interesting. We were trying to really get at what do people do when they're given too much stuff. So we did a series of experiments where we basically tried to create a simulated sort of intelligence analysis scenario. We give these people, computer scientists, PhD people like you, intelligent folks, right? But limited in some ways. We asked them this fundamental question, You're going to make sense of this. How do we measure your behavior? How do we get inside of that? So we did some easy things. We created a test corpus. We created a TLDR universe by going out to GigaWord from LDC, and we basically created 6 corpora. That's them printed out. right? Each one is roughly 300, 400 pages. And they're all basically the longest articles we could find on 6 different cities. And we chose purposefully obscure cities that nobody knew about. And if you knew about it, you couldn't be in our study, right? So trust me, nobody knows about the logging issues in Paramaribo, right? We did have to disqualify somebody from Russia because he actually knew about the military trials in Vladivostok. But generally speaking, these are pretty obscure things. And so this is kind of a big chunk of work. We went through and basically created these test corpora. And then what we wanted to do was set up a test context. So here's the context. Your boss is going to go to Vladivostok, Suriname, or whatever, and needs to know the following kinds of things, right? And you need to write up a report for him or her. Okay, so we did, in order to evaluate this, we wrote a series of 30 to 40 questions, average to 30, questions per city, where we actually hired somebody to go and read that stack of paper and understand it, a historian, actually from Stanford, turns out. And he sat and read through all of them and wrote 30 questions. Obscure questions nobody would know the answer to unless you read that text. Right? So a sample question, right, would be, in 1998 Vladivostok mayoral election, what were the 3 key issues in the race? I know now. Okay, but this is the kind of test we created. So it was kind of a hassle, but we did it. And what we were doing was actually testing 3 different conditions. We had condition A, the folks who actually gave them the paper. Okay, and we'll tell you all of them ripped the binding off instantly. The second thing is we made a couple of simple visualizations. One was kind of semantic clustering, another one was kind of a temporal view. And we baselined this by basically testing it on a whole set of people at IBM at the time. And we discovered with this test we can get very smart people to perform a chance. So we knew we had a nice baseline. Okay, so we run it in these 3 different conditions, paper and 2 different visualization tools that were very simple. This is not the pinnacle of visualization, trust me. Right? Okay, here's a simple one. Time-based view, you could manipulate the axes and time and all that jazz. Each dot represents an article. The color was the amount of how old it was within the set. Right? You could click on the article, click on the node, see the thing, manipulate the variables and all that jazz. Number 2, we had a sort of soft semantic LSA-based clustering mechanism with auto line divisions drawn in here. Same kind of mechanism. Click on the thing, get the link, so on. See the article. You could get detailed views. You could get sort of the raw HTML, or you could see the beautiful, pretty printed format. You could have n of these open at any one time. But you had sort of standard window like this. Okay? So here's the punchline. I will spare you all the gory details. It totally flopped. Totally failed. We built 2 different visualizations, and the fact that this is number of questions correct out of the 30 set. Paper totally wins constantly under all conditions. Okay? Pissed me off. But you know, you learn stuff by this. The interesting thing is, after 5 minutes, the variance, the paper is really winning, right? And the answer is obvious when you watch the videos. People know how to deal with this. They have a lot of space. They can move stuff around. They can manipulate paper very well. They all had decades of practice every single day. We gave them 15 minutes of practice with our visualization tools. Okay, that didn't work out so well. Okay. So we thought, well, we'll step back and try to watch. And so we videoed another batch of people using 3 different tools, again, paper and 2 different visualization data set systems. So that's my desk in my office. And you can see people are moving stuff in and out of the hot zone there. So that's actually in the middle of somebody doing one of these analyses. So they've got notes here, all the usual accoutrements. Here's the interface for one of the other systems. So you could do find and searches within the document space, all that jazz, right? We then coded every 5-second interval in all of the participants. That took a long time. So we did this, and basically it's all color-coded and blah, 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 right? Okay, I've got another vector that goes out to about, I don't know, The next building, right, of these. And the thing, when you step back and squint at it, it's junk. I mean, there's nothing there other than people, the only thing we discovered after doing all this work is that people in the paper condition, which is, it's from here over. It doesn't matter, all the rest of them look the same, right? The only thing about paper is that people would spend larger chunks of time doing anything, one thing. Whereas when you had the electronic versions, it was all fractured up like this. I can give you the exact numbers and all that, but it doesn't matter. People, when they're using paper, focus on a particular subtask and stay on it for longer than they would on the electronic version. So it's like, you would put them on the screen, they get ADD. Okay? So when they're not using paper, yeah.
Quick clarification question. Did you do anything in particular with the organization of the paper? If I imagine you could take temporal or clustering results and use that to how you organize the paper space.
Yeah.
So removing the digital manipulation, which may be what you're measuring.
Sort by time, but it didn't matter.
Or cluster by...
I'm telling you, it was sort by time. And it didn't matter because people, like I said, tore off the binding and then like this. They sorted it to however they wanted. And truthfully, what everybody did was they started putting it in stacks by topic. Okay, here's politics, here's economy, here's agriculture, here's transportation. They did that uniformly. So what we found was that people read less. They cluster less using all these electronic tools we give them. And we tried hard to try to make them facilitate those actions, and it sort of didn't work. So, so why is it hard to read? Is it just the screen resolution is crummy? You know, so we did a whole set of studies on that. That's not the salient thing. What we did discover, well, I'll tell you what we discovered in just a second. But we really started to think about the pragmatics of these tools and what the costs were in the use of the visualizations. Right? So one of the things that we tend to do as a computer science info-viz culture is cool info-viz. Right? We've all done this. Cool info-viz. And it's now becoming more popular to actually step back and evaluate that with respect to whatever the competition is. But here we had a very clear loss. We were totally losing here. So we wanted to understand what people were doing, and one of the implications that came out of that study was that we found that people were spending a huge amount of time switching back and forth between note-taking and their analysis and whatever tool they were using to look at the data set. That was hanging them up. So the cost of looking up a particular piece of data and taking the note just killed them. It was where almost all the time went. So we thought, well, what can we do to understand what it means to do this kind of work in high volume? So we did another experiment. At this point, we're running out of experimental subjects, right? We literally had to, we had to do everything to find these people. But anyway, we ran another study, and the interesting thing here was those were the first two versions, and then we added a third version, which allowed you to easily edit the representation. Right? So here we have each document has a title. You can drag it now and move it. This seems obvious, but in the previous ones you couldn't. So you could drag it, and if you don't like the clustering in Pakistan, you just move it over here to Nepal, right? And so you could fix data errors, data quality errors, easily. You could click it open. You could then do all kinds of stuff. You could change the color. You could add these labels. We made it a much more flexible, what Austin Henderson would call a pliant system. You could edit in the margins without having to declare it formally. And that turned out to make a huge difference. So here is the winning graph. This is the money shot, right? This is the system we just built here. So this is the amount of time it takes for someone to read a new document, they haven't seen before, get to it, and then to come back to it. Okay? That's paper. We beat paper. We were totally happy. Yeah, it was great. And the other two systems, they were two different. You know, that's the old one you saw before. This is one of the new ones. It didn't matter. They were terrible. You know, you go to all this trouble to run these statistics, and it boils down to it didn't work. Okay. This was then moving and reclassifying documents in these systems. Again, the Grokr 2 system was much better. And it was because of these small changes we had made to the cost of changing the representation, changing the sense you were making of the thing. So what ended up happening is that with this new system, people had more time to spend actually doing work and not futzing around. Not, for example, remember the colored diagrams? Lots of switching back and forth switching. That's what was killing them, was switch time. They were thrashing, effectively. And so by doing this, we moved them into more contentful, oh, that's a nice pun. They were more contented and they were doing more content-based work. Right? So the moral of the story here is that the details of the user experience matter significantly. Seconds really do end up making a difference here. So now, from my perspective at Google, we're making the problem worse. We're giving you even more data, right? You don't think you have enough now, we're going to give you exabytes more. Right? Or rather, the web will do that. We're just happy indexing it, right? But now you've got not only web pages and news articles, but images and videos and all that stuff, right? We're giving you new ways to search through that space, as well as more content. So we're adding to the variety, and so if you do a typical research task, now you've got a bunch of stuff you've got to go find and then organize and use in some way. It's all searchable. You type in a query like, what's the population of Japan? Google will tell you, and tell you when that sample was taken. How tall is the Empire State Building? You can get that answer. We can tell you in meters, that's easy. We can tell you in cubits, we can tell you in parsecs. It's true. How tall is the Empire State Building in parsecs? It will tell you. 20,000 leagues in miles, okay? So you can discover all kinds of stuff, and so you can manage a quick question like, what is the airspeed of an unladen swallow? African or, no, come on. Okay. And the way you can ask questions is changing. So I assume you all know a little bit about Google Goggles, and so I can, for example, walk out here and take a picture of Hu Tao and do the query and get the answer in a couple seconds. I can query reality. Okay? I can now take those images, and now you know we've got search by image, so you can reverse the image link. It used to be that if you saw a picture in a paper or in an academic result, and it wasn't subtitled or referenced on the bottom, you were kind of screwed. You couldn't figure out where it came from. Now it's trivial. Dump it into Google image search and you can figure it out. Okay? The quality of the way we ask questions is changing as well. So if I ask you, for example, if you're at a Iris session and a song comes up, you can't Shazam it. Why is it you can't Shazam it? Well, Shazam works with copyrighted material because it creates a giant signature file and all that. But this is live performance with a bunch of people who don't know the part. But I can run this, and so let me actually show you a little video clip here, just because it's fun. This is me at a session. Hey, that wasn't right. One more time. Here we go. This is me at a session, and they start playing a piece. I have no idea what this is. So I whip out my recorder and hit record. I get home, and using my wife's iPhone, I play it back to TunePal, and playing it back from my Mac into the phone. It sends it off to the server in the sky, and it queries this real-time performance. And it's thinking. And what it does is it gives you back a ranked list of possible matches by probability. And so what will happen is it will actually show me the list here. And this is great. So it says it's Lafferty's with 53% confidence. And so I say, play the MIDI file. Right? It's in the same key. So it's not only the right one, but it's in the right key. So this is an interesting shift in the way we think about getting information out of the world. Okay? So more generally, we have all kinds of data available. So Google has been doing some curation of public data, and we've put a lot of different data sets in the Public Data Explorer, and you can go visualize them and play with them that way. You can do experiments like this. This is the unemployment curve for Santa Clara County for the past 2 decades. I can now contrast Santa Clara, for example, with Imperial County and start to understand what agricultural economies are like in terms of their seasonality. Okay? Simple visualization, simple data set. It's all out there available for you to use in making sense of something. So I want to argue that there's actually an interesting shift that's happening. It used to be we would look stuff up, and then you'd turn to your desk or to your buddy, and you'd sit down and do the research and the analysis. Okay? Now, increasingly, we can blend search with sense-making and analysis all simultaneously. So this is my favorite little example because it's the smallest sense-making problem I've been able to come up with. Okay? If you know the answer to this, don't say it. Just let me, amuse me for a moment. Where does 10 fit into that sequence? Just out of curiosity, how many people know the answer? Okay. Good. Only one. Excellent. Okay? So what do you do if you're trying to make sense of this? This is a data set, the smallest possible data set I can think of, and the question is very well formed. What's the answer? So I think I'm a sense maker. I know what to do. I have some competence in making sense of data sets like this. So I pour it into a spreadsheet because it's easy, right? Because I can then start to evaluate alternative explanations for that data. I can do it side by side. And so you know what goes on here, right? You then take that sequence and you do operations on it, trying to find a pattern that leaps out at you, right? So you might do a Fibonacci evaluation. Does n plus n plus 1 equal n plus 3, all that, right? So I fool around with it, nothing is coming, nothing is happening. So then I do a simple dumb thing. I just sort, right? I know the first one is a sequence, but now I can see that's actually integers by 10, right? Okay? Isn't that a striking fact that someone gave us this weirdo sequence and is asking us to insert the one missing integer, right? The 1 by 10. So here's an easy operation I can do. Let's write them out. Now does anything leap out at you? Yeah. The answer is it's alpha sorted. Right. Of course, you would have seen that eventually, right? Or maybe not. The point is, I went through a sequence of representation shifts, and I got it to a point where the representation basically made it trivial for me to see the answer. You would have seen it, trust me. You would have. You're all smart people. So the shift here was that I went through a set of changes in order to get to a point where I could now understand what's going on. And so this is a sort of the smallest possible sense-making story because it embodies this notion of searching for a representation. Here's another kind of analysis I want you to think about. When it rains in Seattle, I know it's snowing at the moment, but Mary, have a good time. Is it qualitatively different? I mean, I've been to Seattle, and it seems to me Seattle feels different, right? But I'm in Palo Alto, it kind of rains and stops, and rains and stops, and rains and stops. So what you can do with this is very easily go out and actually grab data now, right? With about 30 seconds of searching, I was able to find a couple of different data sets. I can go get them 5-minute samples. I can find comparable days. I can take 3 days of data sets using the obvious query, get the CSVs, dump them, do the obvious analysis. And this is actually comparing 3 different randomly sampled days from Palo Alto and Seattle, 0 aligned, so the start of rain is here. And that answered my question. The blue curve is Seattle rain. When it starts raining in Seattle, it starts raining and rains for 8 hours straight. When it rains in Palo Alto, you get these nice little bursts. Boop, stop, boop, stop. A lot of rain, stop. A lot of rain, stop. Stop, stop, stop. Okay? That's the analysis I needed. Yes, it's qualitatively different. Better, worse, I don't know. Let them worry about it. But I now know the answer. And it took me 5-6 minutes to do this. Okay. So what I'm able to do is, in this case, the representation search was simple. Grabbing the data would have been tough to do pre-web. Now, one of the things to be thinking about as you're thinking about your sense-making practices is what are the tools that you can use in order to get data, in order to do those kinds of analytic steps that help you out. So there's an easy way in spreadsheets to go and, for example, write a little piece of script like this. Look up this term with this property, and then populate the spreadsheet. So the spreadsheet is answering the question, which of the Fortune 200 companies are older than 100 years old? Question for you. How long would it take you to answer that question? Well-formed question. Trust me, I looked. There is no list of companies older than 100 years old. Right? So it's easy for me to do a little computation, write a little piece of code. You can write it in Perl, whatever. This allows me, in just a matter of moments, to download effectively the results of a query set, compute the histogram, and so on. You can set up alerts to do something similar, where it's automatically running a query for you, feeding data to you for your sense-making operations. Okay? So what's happening to, I think, in the past decade has been this increasing growth in sense-making repertoire to be more than just search and then offline processing. It's actually now you're able to start to do something more sophisticated. And let me give you a couple of quick examples. Okay. So the first one I want to talk about is Needlebase. Has anybody talked about Needlebase here before? Okay. So Needlebase is a company we just acquired. And basically what it is a crawler in a box with a set of data extractors. Okay? So you can point it at a website. You can say, look at this let's take a website and point it, and I want Needlebase, the tool, the web app, to crawl those sites and extract the following data from the semi-structured data underneath it. So for example, you can imagine crawling a website of papers and extracting titles, authors, dates, institutions, and so on. You can set that up, hit go, wait 8 hours, come back, and you have the whole site crawled and dumped into a database. So you can then do queries against it. Okay? So for example, you could crawl multiple data sites, get all these different references. There's a mechanism in there to do automatic alignment of terms, and so you can automatically get some data cleaning out of that. See, all these references are to that single entity up there, the Capitol Grill in Boston. It goes into a data set, and now you're good to go. So it's a little, yes, I know computer science students at Stanford could write that code, right, in a little Python. It's not that hard. But this is a tool for anybody. So for example, here's a website, populartechnology.net. And if you look at it, you'll see it's kind of a climate change skeptics site. And what they purport to do is to collect a bunch of papers on the topic of climate change skepticism. Fine. So one of the guys at Needlebase wrote a little crawler in Needlebase and said, crawl through all the papers on here and extract out author, title, date of publication, journal, and so on, right? And so here are the data sources he crawled. And now you can go and use their GUI interface to ask questions. In this case, it's showing which authors are grouped most commonly together, which pairs of authors are grouped together, and how often do they write papers, and in how many journals have they had publications sorted by time units, 83 to 2007 and so on. Okay? So you can do those kinds of things basically by launching a bot into the world and having it crawl for you. That's a phenomenal thing. It's kind of like my Fortune 200 question, except it's at a higher level of abstraction. It's doing extraction and abstraction and data cleaning for me in ways that would be difficult for me to do manually. There's another tool at Google called Fusion Tables, where basically you can create these nice tables. You can do joins and foreign keys and all those kind of nice operations, but you can basically take data sets like this, and then there's this suite of visualization tools. None of them are particularly sexy, but they're all kind of robust. So map alignment, heat maps, et cetera. You can use it for something like this, where the folks at The Guardian took the WikiLeaks documents, extracted out all the incident reports, and then dropped them by looking at their geocode location onto a map of Afghanistan. And now this is an inspectable, interactable, queryable map, which is the data extracted and visualized version of that. Right? Fairly simple operation. For us, this is probably a couple hours to do because you got a lot of data cleaning, a little piece of code to write. But it's not that hard. Before, it would have been effectively impossible. The third tool I want to point you to is a tool called BigQuery. It's a version of a tool we have at Google, which basically allows you to upload all kinds of structured data to it. And there's the URL. basically what allows you to do is upload billions of rows of data and then do the obvious SQL or SQL-like kinds of queries. Obviously, for computational reasons, some of those joins are not going to happen. We restrict those. But there's not a very simple APIs. It's a REST API for people who want to program in that. What that allows you to do is upload literally billions of data sets, billions of rows for a data set. And then you've got this whole set of SQL queries you could do. So remember my hypothetical question about do you create a SQL query, SQL data set? Well, it's not that hard. You can do something like this. Here's a nice example done by the guys at Google I/O in 2010, where they uploaded all the edits from Wikipedia. So, you know, I don't know the size of the data set, but it's in the high millions, right? And then you can very quickly do things like where Wikipedia namespace, blah, blah, blah. You can then do extraction, you know, which articles are most edited. There's the count, and that was the article. Imagine my surprise, right? You can very quickly find most edited articles in a matter of seconds. You know, it's interesting, Michael Jackson, which was the highest ranking query of all time, ranks right up there, but half of what George Bush did. Okay. Then, of course, once you're in this universe, it's very simple to write a small amount of scripting that would then allow you to export that data into a Google spreadsheet with simple visualizations. We have a charting API and tools as well. There's a bunch of stuff there you can do. It's fairly straightforward to make these small things. And my point is not that ours is best. There's all kinds of stuff. Jeff's got magnificent things, right? Beautiful visualizations. This is really easy to build, right? That's it. That's the JavaScript to get that to work. Yeah, I know. I'm putting the data into the expression. But for lightweight sensemaking, this isn't quite consumer level stuff. It's sort of prosumer. It's at that junction between expert and beginner. But it's a very simple thing to do, etc. So what you're seeing in all of these tools, and I think in the general direction and trend of the web and sensemaking in general, is that these are all driving those costs in that model down. So for example, instantiating and maintaining representation, Fusion Tables allows you to do that very simply. It's giant spreadsheets, which have all those nice properties that spreadsheets have. They're simple and people understand them. They're linked to the more sophisticated analytics. So there's a bunch of stuff you can do here. It's all trying to get to a point where sensemaking is really about supporting your search for understanding. These are the tools and methods and principles that you should be following in order to get to a deeper understanding. So one of the things that's important here is that we do things like representation shifts and getting the encodons instantiated. It's the ease of doing that that actually is so critical. That was the point of those earlier experiments. You change the time constants, you change the cost constants for any of those functions, and suddenly it becomes impossible. So as I demonstrated there in the last little bit there with those Google tools, there's a bunch of tools out there, and more are coming. That's an important bit at the end. More are coming. Not only is more data becoming available, but the tools are becoming increasingly popular, increasingly easy to use, and it's essential that you, as an academic, learned scholar, know at least some of these things, right? I've hammered on this point, but it's crucial to understand. Simple example. I don't think I've told this audience, but I've told other audiences. The simplest search command in the universe is the Control F or Command F. Okay? You need to know that if you're ever going to do any sort of real reading online, in order to be able to find the presence of a term in the document. And if you don't know what's in there, and you don't know that trick, you're going to spend a long time looking. I recently did a set of experiments where I found that among mechanical Turkers, you get this beautiful bimodal distribution. One peak, another peak. Factor of 20 difference, okay, between 10 seconds and 200 seconds, which is the means for those two peaks. Fascinating, right? I would argue the people out here who don't know that fundamental search trick, the fundamental find trick, are essentially disadvantaged. If they're trying to do something with complex sense making under time pressures, under accuracy pressures, they don't know how to function. And so it's important to all of us that we understand these kinds of things. So a couple of things to keep in mind. The data is growing constantly. The web is getting bigger. We're indexing more stuff. Tools are getting bigger. They're getting more complex. They're doing more things. There's a couple different things I recommend, but the one thing to take away is this is part of what you now have to do. It used to be that you could learn how to do differential equations and you could be an engineer. That was it. You kind of were good for the next couple decades. Now, if you don't watch this stuff sort of day to day, week to week, it's going to get out in front of you, and you will be as though you didn't know how to use Control F. Okay? Thanks. Now we can answer your question, or we can let somebody else ask a question.
Can you put the last slide up there? I wasn't able to.
Oh, sure. There you go. So so this is all basically recommendations about ways to do that. That last injunction I had. I write a blog. Everybody writes a blog, but I write specifically about sensemaking and search. The official Google blog's not bad. There's a bunch of other ones that are nice. Inside Search is one. Search Engine Land is good. You know. Just important that you are aware of these things. Okay, so to answer your question, Jeff. Yeah, populations vary a lot. With a simple example of the Control F thing. For example, in the US, Internet English-speaking users, 90% do not know how to do that. Very fundamental thing. Teachers, it's like 50-50. Okay? Mechanical Turkers, it's 50-50, which is interesting. But this, if you ask different sets of people what their sense-making needs are, mostly it's how do I buy a new refrigerator, right? How do I compare digital cameras? How do I figure out how to pay for a school for my kids? And the tools and methods and sort of base understanding of representations each group has varies tremendously, right? And so the stuff I'm showing you here is really intended sort of for this audience. So it's really scholarly people who know how to write a regex, right? And I wouldn't recommend this to my mother, for example. But I would recommend, for example, using a simple spreadsheet to track and analyze and keep around different options for comparison purposes. So I think you have to choose the tools depending on what your population is, what they know.
I think that answer brings up a really interesting issue, which is for many of the examples that you've shown, and I think most examples we encounter in everyday life, we can rely on Google or some other infrastructure to, in some sense, pre-masticated some of the information for us.
Yep.
And this is where I think your needle-based example was a bit different. And so I'm curious, going forward, I think there's probably a role for at least two different, maybe qualitatively different types of approaches, but I'd love to hear your thoughts on them, which is, to what degree do we rely on the Googles and Bings of the world to figure out what the common information needs are, and then we get these nice tools that will evolve further and get better UIs, or we put perhaps more sophisticated tools in the hands that allow more of this initial stage sense making where you're going out and collecting the information and you're not relying on another service to sort of figure out what needs to be crawled and indexed for you.
Wow, interesting problem. There are people always going to want to tweak the knobs and parameters, and those people kind of know who they are, and that's fine. I think one of the big issues that we all confront, being in us and everybody, is how do you know what to surface, in advance of people actually wanting it? So, for example, when I was doing my field studies about the Control F thing, I'd constantly ask people who didn't know it, do you know any way to find that faster? They'd say, no, what do you mean? They couldn't conceive of it. They couldn't even articulate that they had a need, right? And so that's sort of the problem that we find ourselves in. How do we know what the need is in advance of knowing it, right? It's kind of a chicken and egg problem. So I don't know any good solution for that other than pure inventiveness. I don't know. Yes, ma'am.
You're redefining what computer literacy should be.
Absolutely right.
Because it seems to me that there's been a long, studying computers means learning to program in school. And when I look at...
Actually, I think a lot of schools, it's using Word.
Or now it's using Excel, that's right, using applications. Right. And yet, when I look at my own sons who are in high school, they use Google all the time, and they are constantly being asked to look for things, but nobody's told them how to do that or how to use any of these tools. It's assumed that they'll just sort of figure that out themselves. So it seems to me that there's an interesting educational.
Thank you. Over there is Tasha, who's my colleague, my co-conspirator in crime. We are the Search Education Evangelism team at Google. And yeah, exactly. No, I think that's actually right. There's a big problem in knowing how to search. I mean, I think it was tacitly assumed that, of course, you would all become experts with using search engines after just a modest amount of exposure. And that's patently not true. I have endless studies to show that. But I think teaching that we have to figure out where to fit it in the curriculum. There's no natural spot for it right now. And so that's one of the things that we're struggling with, is how do we get it into a place where it fits naturally. If only. Yeah. So there's approaches like that, like Dave says. Maybe we should make it all online and accessible that way. But I taught a class last week of teachers, San Jose, and so I taught them the Control F thing. Of course, I teach them Control F, right? It's the first thing. And a woman in the back raises her hand and says, "Where am I supposed to have learned this?" And she's right. She's right. There's no place.
So let me ask a quick question.
Yeah.
Is there some book or article or something for somebody like that to go, these 10 of us?
Yeah, I got a bunch of them.
I don't want 1,000, right?
Yeah, right. Yeah, you want. An interesting problem with this is the moment you publish anything like that, it goes out of date. But there are online resources you can look at, and I can send you a link to our website, which has a small set. We have them. The content right now is targeted for teachers, so they can go teach their kids. So, kids won't say, "Why didn't I learn about Control F?" And among high school students, depends on where you ask, what your city. If you're in Palo Alto, you get one answer. If you're, say, in Mariposa in Eastern California, a less, well-endowed infrastructural place, it's the opposite. So there's no uniformity, and it's a huge problem. You had a question too, right?
Yeah. So in this experiment where you're comparing paper with online tools, it seemed that paper had an unfair advantage in that your desk is larger than your screen. Mm-hmm. And what I noticed is that
it's reality, man.
Well, maybe not for that long. In Rocker 2, you had this little notes that effectively reduced the size of articles, so you sort of evened out the conditions. So have you looked at the effect of size and are looking at, if I have a wall instead of just a desktop monitor, does it change this?
That's a great question.
Another question, did you imply that you can look at all the spreadsheet in Google Docs? Or is that?
No. Good question. I cannot look at all the spreadsheets in Google. It's an important point. We very carefully asked people if they want to participate. So these were, people who then gave us permission. So it wasn't nothing sketchy there. But the other thing with the size, it's been one of these big challenges, I think, for our field. Is I now have this monitor and it's giant, right? Now I have other problems. I think Stu's got the world's biggest monitor, or used to, in your office at Park. Right? This giant, 10 by 10 grid or whatever it was of monitors.
You could do a variant of the analysis you need by computing when you're working.
Yes.
For this, and see how that compares to the size of the screen, so you can sort of predictably.
Yeah.
But I had a question I wanted to ask. Isn't there sort of a built-in tension between Google on the one hand has this elegantly simple way of searching. You just plop anything in the box and it does something usually reasonable. But on the other hand, there's this whole elaborate, almost secret language of the, it starts with you can type in movie houses near you and movie names, and then you can type in things that will convert units, and then you can convert currencies for you, and then it gets into Boolean, elaborate things. And I think they don't even want to tell you those things because they want to be able to take them away.
Yeah.
So it's an internal building. But those things are really, really quite powerful, like just using this site colon keyword.
That's right. So you put your finger on a huge internal discussion, shall we say. There's one side of the house that says the more we can automate, the better it will be for everybody, and there's a certain truth to that. You know, for example, spell correction turned out to be a huge win when the spell correction got turned on in Google. Nobody asked for it. Nobody asked for it. 0 people in the universe asked for it, but huge behavioral difference. So one thing that is always, you know, when we add new stuff, there's an element of magicalness to it, and that's good and bad. The good thing is when you stumble across it, you have this wonderful feeling of, wow, it's a great delight. The negative part of that is it's difficult to discover. So I don't, you know, ask me again in 5 years how this debate pans out, because it's a debate we're constantly having. One of the things I do in my studies is I basically turn to the search engineers and say, you know, if you do it this way, you're going to get X more % coverage, right?
But only if you capitalize the Boolean term.
Well, no. You can get or, but not and forget about not. How about that? Yeah, yeah. No, I'm just capital N, capital O, capital T. Forget about it. Yeah, you can use minus. It's not really a Boolean not. It's actually exclude. But anyway. So yeah, but capital OR, not lowercase or. Capital OR.
So the answer
Using
to
it with Apple's Spotlight.
Yeah. Any
Natasha wanted to say something.
it wasn't.
Okay.
He's used to me
Yeah.
getting all excited.
All right. Thank you. Thank you all for coming.
For more, please visit us at stanford.edu.